Okay, today's video, what I am going to do is walk you through predicting one of every single type of reaction. You've watched the video for 8C part 2, and now I'm going to walk you through at least one sample. If you can make sure you have your journals out, also please make sure that you have out Unit 8 assignment number 2, and we're going to flip over onto the back side that says Chemical Reactions Unit 8. I'm going to do a few of these together, and then you'll get some time to work, and then there'll be expectations for the rest of the block. Okay, so first of all, I want to refer back to, if you look at these directions, it says to identify the type of the reaction and then also predict the products. You do not have to include states. I typically do not make you do states when we're doing predictions because it's one more thing to worry about. Now, the first thing that you can do is to try to identify the type of reaction. And if you reflect back on the concept map we made the other day, we've got 5 kinds of reactions. You've got synthesis, where you're going to take 2 things and put them together. Decomp, where you take 1 thing and split it apart. Single replacement, where you have an element and a compound on both sides of the reaction. Double replacement, where you have 2 compounds. And combustion, that involves oxygen. So if you can identify the type, you've got a pretty reasonable shot at predicting what's going to happen on the other side. So if we look at number 15, okay, number 15, you have C2H4 and you're reacting it with O2. All right, so this is going to be a combustion reaction. I'm going to solve these on this screen over here. So for number 15, oops, let's try this again. There we go. Number 15, your reactants are C2H4 and you're reacting it with oxygen gas. Now, this is the combustion of a hydrocarbon. A hydrocarbon is anything that has carbon, hydrogen, and potentially oxygen in it as well, and it will always have the same 2 products. I mentioned this on the video earlier, but the 2 products are going to be carbon dioxide and they're going to be water. Okay, every time you combust a hydrocarbon, we've seen this when we've been practicing balancing, that's what it is going to be. Now we have to go ahead and balance the equation. So if I start right here with the carbons, I have 2 carbons on this side of the reaction, so I'm going to go ahead and put a 2 in front of the carbon dioxide that is a product. Now when I do that, after my carbons are now balanced. Now that my carbons are balanced, I'm going to go to the hydrogen. Well, I have 4 hydrogens over here on this side, and so that is going to mean that over here I need to make sure that my hydrogens are balanced on this side. So now I have 4 hydrogens on each side. Now the last thing I do is balance the oxygens. Well, 2 times 2 is 4, and then I have 2 more over here, so I have a total of 6 oxygens, which means I have to put a 3, so now my oxygens are balanced. Okay, and that's it. And also remember identifying the type. This one is going to be a combustion reaction. Okay, so there is your sample on predicting a combustion reaction. Now, if we look at number 16, okay, first off for 16, I have iron 2 chloride and potassium sulfide. I have 2 compounds. Okay, now again, I am overgeneralizing. I am not covering every single potential type of chemical reaction, but for the purposes of right now, when you have 2 compounds, you can think about double replacement, and that's going to allow us to predict it. So again, if I come back over here, if I write my reactants, I have, and you may need to do this in your journal, iron 2 chloride plus potassium sulfide, and I know they have to switch. Now when you have a double replacement reaction, the good news is all you have to do is switch the cations and the anions. So what I'm going to do up here is write the charges of those ions that's going to help us make a prediction on the other side. This has to, first of all, if I come over here to the first one, chloride I know is a 1-. So that means that since this 2 is here, this has to be iron 2. Then if I come over to potassium sulfide, again I know potassium is always going to be a 1+, and sulfide is always going to be a 2-. So now all I have to do is pair up the new cation with a new anion, and the cation and the anion. Alright, so when I do this, I'm going to start with the iron just because it's first. It wouldn't have mattered. But I have to pair up the iron sulfide. Iron's a 2+, sulfide's a 2-. So my formula for iron 2 sulfide is going to be FeS. Don't worry about the states. We're not going to worry about doing that right now. And then for potassium chloride, I always put the cation first. So potassium's a 1+, chloride's a 1-. So it's going to be KCl. Okay, now the last thing I have to do, again, all you do is flip-flop the products on the other side. The last thing I have to do is get it balanced. Well, all I have to do to get it balanced is put a 2 in front of the potassium chloride. Okay, so that's going to be a double, how you predict a double replacement reaction. Identify the ions, flip-flop the pairs, and then you repair them up over here. You don't have to put the charges up here. I was just showing you to help make a little bit of sense of that. Okay, if we come to number 17, you have barium and you have oxygen. Now, in terms of a type, if I write these out over here, because you're going to need to write them down anyway. Also, I will put this video on the announcements, so you will have access if you need to hear this again or listen to it again. You will, as always, have access to all the videos that I do. Okay, we've got barium and we've got oxygen. Now, I'm starting off with two elements. Whenever you see two elements, you need to be thinking synthesis reaction. Even more specific than that, I have a metal and I have a non-metal. So it's going to be a synthesis reaction that forms an ionic compound over here on the other side, and that's what allows us to predict what happens. So again, if I know from my metal and my non-metal, if I write my ionic charges, barium is always a 2+ because it's a group 2. Oxide is always going to be a 2- because it has 6 valence electrons and needs 2 more. When I combine those, the formula for barium oxide is going to be BaO. Okay, remember we wrote oxygen is Hunkel fiber over here because it's by itself. It does not get the 2 because it's not by itself anymore. But we do have to balance it. So because oxygen is diatomic as a 2 as a reactant, we have to put a 2 in front of the barium oxide. We then have to come over here and balance over here as well. And now we've got it predicted. And so for a type, number 17 is either going to be synthesis or combustion. Okay, either one. The combustion, I think, or the synthesis rather, will be easier to identify, but then you'll be able to do those. Okay, now the next, I've got 3 more that we're going to do. Okay, so number 18, well, actually I'm going to skip 18 because 18 is also a double replacement. So we talked about double replacements earlier. All you have to do for the double replacement is going to be flip-flop the ions. So you're going to, 2 compounds, you flip-flop them. I'm going to do 19 and 20 because 19 is going to give us an example of a decomposition, and 20 is going to give us an example of a single replacement. Okay, now how did I know that? Well, 19, you only have sulfur dioxide, you only have 1 reactant. That's it. So if I only have 1 reactant, it has to decompose into something else. So let's do that one first. So if I come over here and do number 19, what I am starting with is sulfur dioxide. And all I can do is split it into the elements. But there's a couple of curveballs because we know sulfur is S. Sulfur, if you remember, in addition to the Hunkel fibers that are found in pairs, sulfur is always found as S8. Okay, now oxygen, when we split it up, is found as O2 because it's part of Hunkel fiber. Now we have to get it balanced. So because I have 8 sulfurs on this side, I have to put an 8 in front of this one. And in order to get the oxygen balance, 8 times 2 is 16, so I have to put an 8 in front of this one. And again, this one is going to be decomposition. Okay? Alright, now if you read number 20, number 20 says magnesium metal is added to aqueous hydrochloric acid. Alright, I've already told you it's single replacement, and I'm going to show you how I know it was single replacement. So for number 20, first of all, let me translate that into symbols. I've got magnesium solid, hydrochloric, remember it's going to be a halogen. Anytime you have an acid, you're pairing it up with H+. Because it's got the hydro in front, we know it's chloride, which is going to be HCl. Okay, now for a single replacement reaction, there's only a few things that will be replaced. A metal will replace another metal. Okay, well there's no metal over here. A metal will replace hydrogen, or a non-metal will replace a non-metal. And in this case, we're going to get the magnesium essentially kicking out the hydrogen. And we will see this when we do the lab. And you've seen this before. This is the fizzing that we get when we put an acid on a metal. So one of the things that we're going to do is we're going to get hydrogen gas, part of Hunkel fiber, so we have to write it as H2, and then the magnesium and the chloride are going to pair up. Now the magnesium is always a 2+, chloride is always a 1-. So for this one, it's going to be MgCl2. Okay, MgCl2. Don't worry about the states when we're predicting. I just want you to focus on the chemistry, and then to get it balanced, I have to put a 2 in front of the hydrochloric acid. Okay, so at this point I have showed you one sample of how to predict every single type of reaction. That should certainly help. You do need to log into my big campus and pay attention to what you have to have done for Monday's class. You first of all will need to finish, if you have not already done so, the rest of the backside of this worksheet. I'll put the solutions to this one on my Big Campus. You also are going to get more prediction practice on this one. I'm not going to post the solutions. I want you to make a valid attempt. Okay, you have the entire block, which means you can at least make a valid attempt on the type and make some type of prediction as to what is going to be the products. There are a few that might be a little bit more difficult than others. Again, you guys know my rules. Make a valid attempt, and we'll pick this up on Monday. The other thing that you do need to get done is pre-lab for the activity series lab that we're going to do next week. We will still get to do the reactions lab that you missed today, and we'll do the activity series lab. So again, check my Big Campus. You'll find a copy of the lab and all the instructions. Be good. Don't let me get a bad report. And as always, I will answer any of your questions. And at this point, since I'm not here tomorrow, we definitely will bump our test down to next Friday instead of next Wednesday so that I can be around to answer all of your questions next week. Okay, I hope that